Hello children, in this session we are going to discuss equations of motion. What are equations of motion? How many number of equations of motion which we have and how to derive the equations of motion. And there we are going to see two methods. Equations of motion can be derived in a general method, at the same time graphical method also. But here by using the graph, deriving the equations of motion is very important. Children, before getting to the topic, before going to start deriving the equation of motion, just let us think what are equations of motion. Come on children, just start thinking what are equations of motion. So if you want to understand that, let us take a situation where an object is in motion. First you think, dear children, in order to describe the motion of an object along a straight line path, what are the terms required? So that we have to think. For suppose here is an object, let us say here is an object. So it is going along a straight line path with an initial velocity u, it is moving. And this object is accelerating uniformly with a, and in a time t, what happens? It attains final velocity v. And here during this journey, it covers some distance. Children, can I say it is also displacement? Of course, because along a straight line path, distance is equal to the displacement. So this is a situation. So these are the terms which are required in order to describe the motion of an object along a straight line path. Children, the equations which gives relation between these terms only we can call it the equations of motion. So very simple it is. Children, try to understand. In order to describe the motion of an object along a straight line path, we need some terms. So there will be some relation among those terms actually. That relation only we can express in terms of an equation. Those equations only we can call it as a equations of motion. Children, here we have three equations of motion. What is the first one in that? The first equation of motion is v is equal to u plus at. First equation of motion. And whereas here second one is s is equal to ut plus half at square. Second equation of motion. Whereas third one is, dear children, here v square minus u square is equal to 2as. So these are the three equations of motion which we are going to discuss how we are going to derive by using a general method and by using a graphical method. And after that we will discuss a few numericals based on equations of motion also. So first let us start with the general method. So this is very simple, but dear children, examination point of view, they don't ask you to derive the equation of motion in general method. Rather, they will ask you to derive the equation of motion with respect, means in terms of graphs, means graphical method only we have to use in order to derive the equation of motion. So first we will see the general method. So to derive the equation of motion. In fact, dear children, even we can derive the equation of motion by using calculus also. That you will be learning in a +1. Okay, first. So let us derive the first equation of motion. Children, from the definition of acceleration. Yes, first of all, you think, children, what is acceleration? Just you think, what is acceleration? How to define acceleration? Children, acceleration is defined as the rate of change of velocity. Means whenever there is a change in velocity, definitely we can say that that object is going with the acceleration. So from the definition, acceleration is written as change in velocity, that is final velocity minus initial velocity by time. So from this, get this time this side so that it gets multiplied. So it will be v minus u is equal to a into t. Then from this, v is equal to, we can write u plus at. That's it. Children, it's very simple. Means if you know the definition of acceleration, then you will get the first equation of motion, that is v is equal to u plus at. Now let us derive the second equation of motion. Children, how distance covered or a displacement relate to the velocity? For suppose, dear children, here is an object, initial velocity is u and its final velocity is v, and the distance covered is s. Then if you want to calculate actually distance, how can we calculate, how can we write an expression to calculate the distance covered actually? You should look at here. So, distance covered is equal to distance or displacement. Distance is equal to average velocity. We have to take the average velocity into time. This is what actually formula which we have to use to calculate the distance here. So, distance is S. Average velocity means what? It's an arithmetic mean of these two. Arithmetic mean. That is what? V plus U by 2 into time. Into time. But dear children, from the first equation of motion, V is equal to U plus AT. So, let it be first equation. So, substitute V is equal to U plus AT here. In the place of here, let it be the equation 2. Equation 2. Now, here substitute 1 in 2. Where we have to substitute? We are going to substitute in the place of V. So, in the place of V, we are going to write U plus AT. So, here S is equal to, we will get U plus AT plus U by 2 times T. Now, let us do the simplification this. What are we going to get? See, it's very simple. Let us here. Let us write here. So, here S is equal to, children, U plus U will be 2U. It is 2U plus AT by 2 into T. Now, these two terms, let us multiply these two terms with the time. Then here we can write as a 2UT plus AT square by 2. So, this 2 is a common LCM. Now, let us divide the terms and write individually. So, here S is equal to 2UT by 2 plus AT square by 2. So, 2 gets cancelled. Then, what do we get here? S is equal to UT plus half AT square. That's it. It is the second equation of motion. Second equation of motion. Now, let us derive third equation of motion. Children, in order to derive the third equation of motion, let us take same formula, that is distance is equal to average velocity into time. Let us see here how we are going to get third equation of motion. That is S is equal to V plus U by 2 into, children, in the place of time, what can we write? Again, let us take the help of V is equal to U plus AT. Children, we know that it is V is equal to U plus AT. From this, what can we write here? Time can be written as V minus U by A. T can be written as V minus U by A. Now, in the place of time T, let us substitute V minus U by A. What do we get? Here, V minus U by A. Children, if you can see the numerator, it is V plus U into V minus U. So, children, can you remember any formula in maths? Yes. A plus B into A minus B, which is A square minus B square. So, this we can write V square minus U square by, it is 2A. So, get this 2A this side, then it will be V square minus U square, it is V square minus U square is equal to 2AS. So, children, this is third equation of motion. Okay, children, this is how actually we can derive the equation of motion, but it is a general method. It is a general method. Now, we will see how can we derive the equation of motion by using a graphical method. Children, copy this. Then we will be moving to the derivation part. Same derivations which we are going to do, but with the help of graphical method. So, very important. Okay, fine. Hope copied. Yes. Let us see that. Now, dear children, in order to derive the equation of motion, now let us take a situation where object is going along a straight line path. Once again, let us consider here. Children, here is, as we thought already, it is an object with the initial velocity u, it is going, am I right? And this object is moving with a uniform acceleration a. Then in time t, let it be the distance covered is s, and v be the final velocity attained by the body. Children, here terms are very important. U is the initial velocity, v is the final velocity, s is the distance, might be even displacement also, t is the time. But here very important thing is that you should not forget that a is here uniform acceleration. Here is uniform acceleration. Children, here we should not forget one very important thing is that these equations of motion are derived for an object which is moving with uniform acceleration, which means what? We can apply these equations of motion only for the bodies which are moving with uniform acceleration only. Otherwise, we cannot apply, we cannot use equations of motion. Okay, fine. Children, so this is a situation of an object. Now, can we represent this situation in terms of graph? Yes, we can explain, we can express this entire situation, entire scene, okay, with the help of velocity time graph. But teacher, let us recall, so how can we represent the body which is moving with a uniform acceleration in VT graph? Children, there we have two graphs. Let us see once again here. For suppose, here is time is taken on x-axis, velocity is taken on y-axis. So, how do we get, means what type of graph do we get if any object is moving with uniform acceleration in a VT graph? So, children, that will be like this. Means no doubt about it, if a body is going with a uniform acceleration, then definitely in a VT graph we will get a straight line. But here question is that, dear children, okay, here we got a straight line passing through origin, no problem. Here we have one more equation, right? Sorry, one more graph, not equation. It is a velocity time graph. Then what does it represent? What does it represent? Children, it is A, it is a B. Children, what is the difference between these two graphs? Just you think. Dear children, here, look at here, it's very important. I'll tell you the similarity, you have to tell the difference. You have to think and you have to tell the difference. So, what is that similarity? These two VT graphs will represent the body which is moving with uniform acceleration only. But what is the difference? What is the difference, dear children? Then just you first pause the video, think and comment your answer. What is the difference between these two? What is the difference between graph A and a graph B? Got it? Yes, let me tell you here. Children, these both graphs represents uniform acceleration only, but difference is that, dear children, here the body is moving from rest, means initially the body is at rest, but whereas, dear children, here body has some initial velocity. Now you think out of this graph A and graph B, which will represent this situation? Obviously the second one only. So, we are going to use this graph to represent actually equation of motion. I mean to derive the equation of motion, not this graph. Children, once again I am saying why not? Because this graph will represent uniform acceleration only, but the body initially at rest. But whereas here body has some initial velocity, so it won't represent. So, this is a graph which will represent exactly this situation. Got it? Fine. Now, we will see how can we derive the equation from this velocity time graph. Let us make a velocity time graph first. Let us make a velocity time graph. So, if we are okay with this velocity time graph, or else let us write simply it is a VT graph. It is VT graph. With the help of this only, we are going to derive the expression. It will be, so here is a time. So, children, as we know that time is a independent quantity, should be taken on x-axis only, whereas velocity is a dependent quantity, should be taken on y-axis. And this is a graph which we got for a situation which we have taken. What is that situation? Body is moving with uniform acceleration, but not starting from rest, means initially it has some velocity, it has some initial velocity. So, children, in this graph, this OA represents initial velocity. So, this OA will give you initial velocity u. OA will give you initial velocity. It's very important. Whereas, dear children, look at here. From here, let us make one line to the x-axis, and here y-axis. Let us say it's a OAB. Let us name it as C, and from here to here, this is going to be D. This point is going to be, let us say it's a E. This point is going to be. Children, here, as I said that here, OA represents initial velocity, and whereas here, OE represents, children, it's very important. OE represents final velocity. OE represents final velocity, whereas here this OC on x-axis will represent t, that is the time. So children, this is what actually we have to understand. Once again, children, OA represents initial velocity, OE represents final velocity, and here OC represents what actually? Time. Children, from this graph, can we write like this? How can we write? Can we see here? AD is equal to OC is equal to T. Of course, we can write this AD is equal to OC. That we can write. Okay, fine. And at the same time, CB is equal to, we can write OE. Am I right? Yes, we can write CB is equal to OE, which will represent final velocity. Final velocity. Whereas the children, this dB equal to AE. Am I right? It's very, very important. dB is equal to AE. That is dB is equal to AE. But the children, what is AE in this? So how to get AE? From this OE, if we can subtract this OA, children, think properly, it's very, very important. So how to get this AE then? Here, from this OE, remove this part OA, then it will be AE only. Let us write like this, that is OE minus AE, sorry, OE minus OA it is, OE minus OA. Children, this is what actually we need. This information is needed in order to actually derive the equation of motion. Now dear children, let us derive the equation, first equation of motion by using this velocity time graph. So what is that first one? Children, in order to derive the first equation of motion, we need to calculate the slope of the velocity time graph. Slope of the velocity time graph. So children, just you think, what does the slope of velocity time graph gives? Very, very important, very, very important. What does the velocity time graph gives? Children, the slope of the velocity time graph gives you acceleration. It's very, very important. Acceleration means here, acceleration is equal to, we know that it is the slope of VT graph. Slope of VT graph. That is what? Slope of AB we have to calculate here. Slope of VT graph means what, children? Here, slope of AB line. Slope of AB line. Children, how to calculate slope? Let us recall slope formula. Children, we know that here slope is equal to y2 minus y1 by x2 minus x1. That is, change in y value by change in x value will be the actually slope. But for this AB, what is that change in y value? It's very, very important. Children, this is what actually y value. Y value, that is dB, and x value will be AD. X value will be AD. Now let us write here. So here slope is equal to, so dy value on for this velocity time graph will be dB by dx will be how much? This will be, so dA will, that is AD. AD will give you that change in x value. But the children, look at here, from that graph only, how can we write dB? Children, here already we written dB is equal to AE, and it can be written as OE minus OA. It can be written as OE minus OA. OE minus OA by AD. AD can be written as OC. OC, look at here. But the children, what is OE here? OE is nothing but OE, from O to E is nothing but final velocity. That is V minus OA is what? O to A is initial velocity. So let us write it is the initial velocity. And here OC is time. OC is what actually time. So let us write it as a time. So here acceleration is equal to, we got V minus U by T. So from this we can write V minus U is equal to, again it is a common thing, but it is a AT, and V is equal to U plus AT. So children, this is what actually we need, equation of motion. First equation of motion, of course we already derived by using a general method, but this is how we can derive the first equation of motion by using a velocity time graph. Children, in order to derive the first equation of motion, what we have to do? Just we have to calculate the slope of velocity time graph. What does the slope of velocity time graph gives? So it gives acceleration. Okay, children, fine. So this is how actually we can calculate, derive the first equation of motion. Just copy it, and then we will be moving to second equation of motion. Copy it? Yes. Now we will move to the second equation of motion. That is what? S is equal to ut plus half it square. S is equal to ut plus half it square. Teacher, here S represent what? What does S represent here? Distance or displacement. But dear children, how can we calculate distance or displacement from velocity time graph? First of all, can we calculate the distance from the velocity time graph? Just you think. Can we calculate? Yes, we can calculate. How can you calculate? By calculating the area under velocity time graph. Yes, children, the speciality of velocity time graph is that from the velocity time graph we can calculate acceleration and as well as displacement or distance. How can we calculate acceleration? By finding the slope of velocity time graph. But how can we calculate the distance or displacement? By calculating the area under velocity time graph. Now let us calculate the distance. Children, second equation of motion here. So here S. How can you calculate S, dear children? By finding the area under velocity time graph. Area under velocity time graph. Children, here, look at here. Area under velocity time graph means this one. This complete area under this green color line is there, right? So under this complete area will come. Means it is nothing but OABC. Trapezium. So we have to calculate the area of the trapezium. Look at here, teacher. So we have to calculate the area of OABC trapezium. So if you can calculate the area of this trapezium, then obviously we will get the second equation of motion. Children, let us recall the formulae to calculate the area of the trapezium. So half into distance between the two parallel sides into sum of the two parallel sides, right? So let us use that only, children. Here it is half into. So what are the parallel sides here? OA, CB, these two are the parallel sides, and here AD is going to be what, children? Perpendicular distance between these two parallel sides. So here half into AD into here OA plus CB or BC we can write. CB or BC you can write here. So how can we write this more? Half into AD is what, children? AD is nothing but OC. AD is nothing but OC and it is equal to time T. Okay, it is a T into OA is what here? OA, from this graph it is the initial velocity, that is U, plus CB is what? Children, CB is equal to OE. Don't get confused that. So here CB is equal to OE, that is final velocity. So here write final velocity. Of course, this is what actually we got. Next, what we have to do? So here only we are going to take the again help of the first equation of motion. Children, we know that from first equation of motion, V is equal to U plus AT. So we know that V is equal to U plus AT. What we have to do? This equation we have to substitute in the place of V. Let us substitute here. S is equal to half into T into U plus, in the place of V we are going to write U plus AT, that is U plus AT. Now let us simplify this. Got it? So it will be half into T into 2U plus AT. Now this T by 2, with this T by 2, let us multiply these two terms inside. So or else first half you keep aside only, keep just outside only. With the time you multiply inside terms. So it is going to be 2ut plus at square. Now you multiply with this 2 inside, that is a 1 by 2 you can multiply. So it is going to be 2ut by 2 plus at square by 2. The 2 gets cancelled. So finally what do we get here? S is equal to ut plus half at square. So children, this is the second equation of motion. S is equal to ut plus half at square. Very simple. Children, how could we do it? By finding the area under velocity time graph, we can derive the second equation of motion, that is S is equal to ut plus half ut square. Okay, children, just copy it. Now we will be moving to the third equation of motion, that is v square minus u square is equal to 2as. But dear children, here one important point is that this logic is that if you know how to derive the second equation of motion, and specially you no need to practice third equation of motion. No need to practice. Why? Third equation of motion also we are going to derive by finding the area under velocity time graph. So what is that area under velocity time graph? Again it is distance only. So children, so here look at here. Now we are going to derive the third equation of motion. How? Look at here. This is the same information which we are going to use. Children, till here everything is same. So let me copy here. Children, till here everything is same. No need to change anything. Again we are not going to derive or specially no need to write. Everything is a time waste. Means once you can practice the second equation of motion, third equation of motion is a very waste. Means indirectly almost you have done even third equation of motion also. Look at here dear children. So here we know that here children, now we are going to do the third equation of motion. Okay, everything is same. Till here everything is same. Now look at here. V is equal to u plus at. Children, from this what can we write here? From this can we write like this? At is equal to v minus u. Of course we can write. From this we can write t is equal to v minus u by a. It's very important. Now what we are going to do this? T is equal to v minus u by a. Children, now this we are going to substitute in the place of time. In the place of t we are going to put v minus u by a. Now let us substitute and see what is going to happen and what are we going to get. Children, here S is equal to 1 by 2 into, in the place of t we will be writing v minus u by a into, children, this is u plus v here. Can we write as v plus u? Of course we can write 2 plus 3 or 3 plus 2, everything is same only. So it will be v plus u. Children, in numerator you can see v minus u into v plus u. Again it is in the form of a plus b into a minus b, which is what? A square minus b square. So this is going to be v square minus u square by 2 into a is what it is a 2a. So here S is equal to, we got v square minus u square by 2a. From this we can write v square minus u square is equal to 2as. 2as. So children, this is the third equation of motion. Third equation of motion. Children, here to derive the three equations of motion, what we have done? Simple thing, very simple thing. First, we have calculated the slope of velocity time graph with which we could derive first equation of motion. Whereas, to derive second equation of motion and third equation of motion, we calculated the area under the velocity time graph. Okay, children? Fine. Okay, we derived. Then what is the use of these three equations of motion? How are we going to use these three equations of motion? Let us see the children. Copy this. Can I rub this? Yes. Look at here. Children, first of all, what is the first equation of motion? That is v is equal to u plus at. So what is the specialty of v is equal to u plus at? Look at it. V is equal to u plus at. V is equal to u plus at. Children, if any object initially, if any object is moving with the initial velocity u and it is moving with some acceleration a, then how can we calculate the final velocity attained by that body in a given time? So if you want to calculate the final velocity, children, if you want to calculate the final velocity attained by a body, we will use this equation when u value, a value, t value is known. Then what about v square minus u square is equal to as? Here you may get one doubt. Sir, why can't we use this second equation of motion to calculate, to find the final velocity attained by the body? Of course, you can use. Either you can use this or you can use this. But dear children, here if you want to use this equation of motion, you must know the distance traveled, S also must be given. S also must be given. Then only we can use this equation to calculate to find the final velocity attained by the body. Whereas third equation, that is S is equal to ut plus half at square. So this equation, dear children, is used to find the distance covered in a given time t if a body is moving with a certain acceleration. So this is what actually very important. Of course, it is not whatever I said is only correct. It is not that. Means depends in the situation. I mean depends on the data which is given. We can modify the equations of motion and we can do the solutions of a given numericals. Now dear children, let us see how these equations of motion are modified in the case of a freely falling body and whereas a body projected vertically upwards. So first we will see dear children, in the case of a free fall. If a body is falling freely, it is called free fall. So in the case of free fall, how the equations of motion are modified? Let us take a situation where here is an object. So it is falling freely, that is moving towards the ground. What is the initial velocity of this body? Children, initial velocity of this body is 0. And here, let it be, here is a distance travelled. Children, distance travelled horizontal, that horizontal distance we can take as s, whereas vertical distance we can take as h. So here we can take vertical distance, s is equal to h, and vb its final velocity before going to hit the ground is the velocity v. And children, here as a body is going in the direction of gravitational force, we can take a as a plus g, a as a plus g. And here, let us question ourselves, can we apply equation of motion for a body which is like falling freely, can we apply equation of motion for a free fall? Of course we can apply. Why? Because dear children, at every point g value remains same only. So freely falling body is the best example for an object moving with uniform acceleration. Very good. So definitely we can apply. Now these cases, as s is equal to h, u is equal to 0 and final velocity will be b, a is g. Let us substitute these equations and let us see how equations of motion are modified for a freely falling body. Children, first equation of motion, that is v is equal to u plus at. So here you put u as a 0 plus z into t. So it is v is equal to gt is a first equation of motion. Now second one, so we know that s is equal to ut plus half at square. Children, here you put here in the place of s you can put a h. H is equal to 0 into t will be plus half g t square. So this is h is equal to half g t square. This is how second equation of motion is modified. Whereas third one, so third one is going to be, children, that is v square minus u square is equal to 2as. Now here you substitute here v square minus 0 square is equal to 2gh. From this v square is equal to 2gh and v is equal to square root of 2gh. Children, this is very important. Of course, all are important only. But what is special of this one, you know? If any object is thrown certain height, with what velocity it hits the ground, how can we calculate? By using v is equal to square root of 2gh. So dear children, this is how equations of motion are modified in the case of a freely falling body. Now let us see how equations of motion are modified for an object which is moving what? Vertically upwards. So the body moving look at here. So body moving means body projected vertically upwards. So here let us take a situation here where here is an object. So it is thrown from the ground vertical upwards. Children, in order to throw the body vertical upwards, definitely some initial velocity must be given. It's very important. Initial velocity must be given. So u is not 0 in this case. And let us say v be the final velocity and it is going to cover certain distance, can be taken as h, and your body is going opposite to the direction of force of gravity. So here a is taken as a minus g. But actually, you know, when you go for higher classes, this is what actually we don't follow. After 10th standard it is okay, but when you go to the higher classes, you know, there the sign convention which we follow is a different. Okay, now it is not needed, it is not required whatever we are going to follow in higher classes. Up to 10th class, what is the sign convention which we follow, only we are doing here. Okay, now let us apply these cases for equation of motion. Children, first equation of motion is V is equal to U plus AT. Now you substitute these things, it is going to be V is equal to U minus GT. That's it, first equation of motion. And the second one is S is equal to UT plus half AT square, half AT square. So this is S is equal to UT minus half GT square. Now third equation of motion, it is going to be V square minus U square is equal to 2AS. Of course here you can add H, or else you can leave as H also, not a problem here. This is V square minus U square is equal to minus 2GH. So this also can be written as V square is equal to U square minus 2GH. So children, this is how equations of motion are modified in this case also. So we have seen two cases where first one is freely falling body and the second one is body projected vertical upward. So in these two cases, how the equations of motion are modified, which we have discussed. So children, so these are the equations and modified equations which we will use in order to solve the numericals. Okay children, fine. So children, this is today's session. So just what we have discussed in today's session. Only one point. What is that? Only equations of motion. So we have discussed only equations of motion. So dear children, before going to end the session, just let us try these numericals. The first one is, I'll give you the situation. Here is an object initially moving with 10 meter per second and accelerating with 2 meter per second square. So initial velocity is 10 meter per second and it is accelerating with 2 meter per second square. Then what is its final velocity? 5 seconds. Okay, fine. And the second numerical is that a body initially starting from, initially it is at rest, body initially at rest, and it is acted upon by some force, initially at rest and it is acted upon by some force, so that it is moving with an acceleration of 10 meter per second square, move with a 10 meter per second square. Then find the distance traveled, find the distance traveled in 10 seconds, distance traveled in 10 seconds. So dear children, there are the two questions for your homework. So just you think how can you calculate this equation of motion, these two numericals, means which equation of motion is applicable for this first numerical and the second numerical. Just pause the video, try the numerical and comment your answer, and next class I'll let you know what is the correct answer for first one and what is the correct answer for second one. Okay children, thank you so much, all the very best.